Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at wireless LAN operation. We'll be discussing 802.1 wireless topology modes, BSS and ESS, 802.1 frame structure, CSMA, CA, wireless client and access point association, and then finally we'll look at passive and active discover mode. This episode is part of my series on switching, routing, and wireless essentials for the Cisco Certified Networking Associate, also known as the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. As we talk about how wireless LANs are configured, how they operate, it comes down to kind of two modes. You can start throwing a third mode into it nowadays: infrastructure mode, ad hoc mode, and tethering. There's some debate whether or not this is technically a way of how a wireless LAN operates. Maybe it's a combination of a couple of ways of the infrastructure and the ad hoc. Infrastructure mode is you have an existing infrastructure. You have your network. We have some switches. We have our network cables. We have servers. We have routers. You have all sorts of servers. You have a DHCP, DNS. You have Active Directory out there. You have all this infrastructure built. And what you are doing is you are providing this access point here. So all of your wireless end devices can connect in. And so this is infrastructure mode. You have an existing infrastructure. You're providing your wireless end devices a way to connect into your network, a way that user can have their laptop connect into the corporate network and see all of those resources on that corporate network. Ad hoc mode is a network that's set up kind of on the fly, and it's typically between two wireless devices. There's no existing network, no existing infrastructure, but these two devices say, okay, let's create a temporary network between us and transfer data. Example here is we have two laptops, two PCs. And what you can do is say, okay, let's set up this temporary network that when we're done using it, it gets destroyed. We don't use it again. If we need this ad hoc network, we're going to recreate it. And so it doesn't connect into your corporate network. It does not provide you the resources of your corporate network, DHCP, DNS, Active Directory, all that. It doesn't supply that. It's just that way. A lot of times we'll see something like this for quick file sharing. Oh, I need to get you a file. Okay, we can set this up. This ad hoc mode is also known by a couple other different names, like airdropping on some smartphones where they automatically see each other and they can transfer data. That's an ad hoc mode. That's an ad hoc network right there, where it's a temporary network that's set up just to transfer data between two devices. And that's an ad hoc network. Tethering, like I said, it's questionable if you consider this another mode or not. And what we have here is in the center, we have our cell phone. And this cell phone connects to the internet through the cellular network. A lot of people consider this as an infrastructure connection. You are connecting your smart device into the cell phone's infrastructure. So they have a network set here. When you connect into their wireless receiver, you then connect into their wired network, which has networking services, DHCP, DNS, all that kind of fun stuff. And so this is an infrastructure connection. This right here between your phone and the device you're trying to connect in, a laptop, a tablet, something like that, you're going to tether to. This is an ad hoc network typically. And so we see that we combine both of our infrastructure and our ad hoc into tethering. And so that's where the argument is. Is this a separate mode, or is this just a combination of both of that? And so we have the cellular network, we have ad hoc. This uses Wi-Fi here to make our connection. And that gives us the tethering that we hear about. And most of us are familiar with this term. It's a hotspot. You have turned your phone into a hotspot. It connects to the cellular network, and then it also connects into a device you're trying to get onto the network but doesn't have a cellular connection. That is the hotspot. Couple more terms we need to talk about: the basic service set and the extended service set. The basic service set is that range that an access point services. It is where that access point has coverage, where that wireless signal is seen by the end user. Now, for every basic service set, there is a basic service set ID, and that is a MAC address. And that's the MAC address of the access point, because once again, every network device has to have a hardware address. It has a MAC address on it. And so this basic service set is served by one access point here, and that's the coverage. If you have a separate basic service set, it has a different BSS ID, it has a different MAC address, it connects into a different access point, and you're connecting there. And if you want to take this laptop here and bring it over to this area, into this other second basic service set, you have to go through a reassociation for that laptop to connect into this access point, to connect into the second access point. Basic service sets, the example here is a lot of times you have your laptop opened up at the coffee shop, you close it down, you take it to work, and then you connect into there. So you're changing networks. And that's what typically we see is you're changing networks, you're changing locations to change these basic service sets. In a corporate environment, we now look at extended service sets, where you can go from room to room and even sometimes building to building in the same company and not have to lose your wireless connection. It gives you some sort of roaming. And what happens here is you have two different basic service sets. We got one basic service set on the left with one MAC address. We get a second basic service set on the right here with a second MAC address. You will connect into two different access points, access point 1, access point 2. But this extended service set covers all of them. And on a corporate network, this is where you would share the same SSID on here. You would have the same SSID, whether you are over here on access point 1 in the conference room or if you're on access point 2 over in your office. It still has the same SSID, and so whatever that is, it's company wireless, whatever you want to call it. Company _ wireless is the name of our SSID. That's when you open up your phone and you say list out the wireless networks. That's what it is, and it would be the same network there, and it connects into the same infrastructure. It connects into the same network, gives you access to the same resources, DHCP, DNS, whatever you have set up on your network. It connects into those same resources, even though you did connect into two separate access points, two separate basic service sets. The extended service set makes it all one big one. I hope you're liking this episode on wireless LAN operation. If you have the time, please leave me a comment and let me know what you think about wireless LAN operations. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. To get this data sent across the network, we have to format it in such a way. In IEEE, they set up an 802.11 frame to get this data across there. And in here, we need to keep track of several pieces of information to get that data from your end device to its final destination. Looking here, we have the 802.frame. Up here, we got a header, a payload, and then the FCS, the frame check sequence at the end. This 802.11 frame, it does error checking, but it doesn't correct for the errors. It does the error checking. It uses a CRC, a cyclic redundancy check, make sure that the data hasn't been tampered with. If it has, it deletes it, and it worries about other protocols worry about getting that data retransmitted. But in this header, there's a lot of information that comes along. Here in the frame control, this first area, some of the things we look at here is power management. how much power do we use on our wireless device? Well, if we're really close to the access point, we don't need to have our transmitter on the end devices broadcasting at a high power, so we can bring that back. We look at protocol versions. What versions of the protocols we're using. We look at the duration, what we're sending. And then we have different fields for addresses. The first field here is the MAC address on the access point. We got to send data to the access point from our wireless. We got to do that. The second address here is the device MAC address. And that is the device of your smartphone, of your laptop. And so they have to know those so they can send data back and forth. The third address is the default gateway. That's how you get on and off of your network. And so where do we go to get that information? Because we have to go through ARP and that type of stuff here, even with the 802.wireless frames, we still need to know where do we send our data to get off of the network. Then we have some sequencing control in there. And then sometimes we even have a fourth address. Fourth address here is typically used for ad hoc mode. We have all of that data in this frame structure. And you got to think of every device you got to go through. You go from your end device wirelessly to the access point, to the default gateway. And you got to keep track of all that. And that's what this 802.11 frame does for wireless. One of the ways we send data across there is the CSMA CA, Carrier Sense Multiple Access with Collision Avoidance. Okay, so what does that mean? Carrier sense, the first part here, carrier sense. We're going to look at our carrier or our media and we're going to sense what state is in it. Is there anybody sending at this time? Can we send? Is it available? Is there any traffic or congestion on it? We're going to look at that. We have multiple accesses. We have multiple devices that access our media. And our media, once again, here is wireless. We have multiple access, so we have to control that. And how are we going to do that? We're going to do that with collision avoidance. This is like driving a car. You come to an intersection. You look left, you look right, you look left. Is there any traffic coming? If there's traffic coming, you don't go. You wait for that traffic to pass. Then once it passes, you go out there and you look again. Look left, look right, look left. If it's clear, you can go. But if there's traffic, you repeat that process until it's clear so you can go. And that's how wireless works. And it kind of goes through 5 states. We do our listening. First, it listens on our network. We see that there's no other traffic out there. Once it's clear, we send an RTS message. This is a ready to send. So ready to send. We send that out. The device sends that out. And so this wireless client over here has done the listening. And it said, okay, nobody is sending out information. I'm going to send my RTS out. That RTS is sent to the access point. The access point hears that request or ready to send. Then that access point checks and says, is anybody else sending at this point in time? If somebody else is sending, they don't send back the next step. If there's nobody else sending, what the access point does is it sends back a CTS. It sends back this CTS. CTS stands for clear to send. And basically the access point says, okay, nobody else is sending, you can send it. I'm also going to reserve and stop anybody else from sending. So that way I can get your message. Then we transmit the data. And so the data goes back across here. Data travels back. We complete that. And then at that point, all transmissions get acknowledged. Access point, wireless client, they send acknowledgments to make sure everybody's happy. Now, what happens when you send that RTS and it's not clear to send? We wait a random amount of time. It generates a random amount of time and we wait. We're talking about time here. And once again, when we talk about time with computers, you're looking at milliseconds. That random amount of time we're going to wait is 12 milliseconds. We're going to wait 23 milliseconds before we try again. So it's not a long time for us humans, but for computers, it's long enough to see, is there something happening? Yeah, we're going to sit here, wait a random amount of time. We're going to wait 23 milliseconds, 21 milliseconds, 12 milliseconds, whatever it is. And then we send another RTS, another request or ready to send. And we start this whole process over again. If the acknowledgements don't happen at the end, and especially when the access point sends back the acknowledgement, what happens is that wireless client assumes there was a collision. And so if we don't get this in here, we're going to assume there was a collision, that the data wasn't received, and we're going to start this whole process over. And so this is where the CSMA, Carrier Sense Multiple Access Collision Avoidance, comes into play. And this is how it works. When your device turns on, one of the first things it has to do is it has to associate with an access point. That wireless client, it goes through a process. When it first turns on, the device turns on, boots up operating system, and initializes that transmitter in your end wireless device. It sends out a discover. It goes out and it discovers access points. It looks for whatever access points are out there. And a lot of times in a corporate environment, you may have 3-4 access points that device hears. It's going to pick out the one with the strongest signal. And then it's going to process to communicate with it. When that discover goes out, we get some authentication messages from the access point. And that authentication here, it says, okay, how are we going to authenticate? And this is where we're looking at WEP, WPA. Typically, you're providing some sort of passkey, pre-shared key, maybe even a username and password, depending upon what authentication you have. After you authenticate yourself, we go through the association process where you connect up and you set up so that you can send data across that wireless connection to the access point. To get a successful association between that wireless device and the access point, we need to agree on a couple of things. That device and access point, they need to make sure that they know what the SSID is, that client knows what the SSID is, the name of the network to connect to. They got to have the password for authentication. They got to make sure that wireless client has the correct password. We need to know what network mode we're using. What 802.11 standard are we using? B, G, N, AC, whatever standard we're using, we need to make sure that it's agreed upon. Then we're going to look at the different security modes. We're going to make sure that security mode is set up. These are the security parameters. This is WEP, WP, WPA2. What security are we doing? And finally, we need to know what channel mode, what frequencies are we going to use. Clients use one of two scanning modes to connect into that access point, to find that access point. They scan the frequencies, and there's two modes that it happens. One is passive, one is active. In the passive mode, that wireless client just sits there and listens for the beacon to come out. That beacon says what SSID, what's the name of the network, the supported standards, the security setting. It sends out that beacon every so often. It sends out that beacon, and then the wireless client that's looking to connect to a network, it knows to sit there and listen for those beacons. And with the passive mode, that access point has to send out that information. Now, if you're going to secure your network and not necessarily have your beacons contain all that information, what we can do is do active discover mode. This is where the wireless client knows the name of the network, knows the supported standards, has any authentication ready to go, and it sends out a request. It sends out that probe and says, okay, I am looking for this network. And then the access point starts the negotiation process. So we got passive, we have active. It was my pleasure to provide you with this wonderful episode on wireless LAN operation. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all of these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.